LM324. Okay, you can see it is a single supply quad operation amplifier. The voltage is between 3 volts to 32 volts. Here's the package, the top view, and what you see inside these are triangles. These are called comparators. We're gonna go ahead to the Proteus and draw the schematic. This schematic here, and then we're gonna simulate to see what is really happening inside the whole circuit. So we're gonna start picking our components that we're gonna use. Let's try to simulate this. Okay, bring this closer there, and LED turns on. We go back, LED turns off. Let's introduce some voltmeter here to understand what's going on inside the circuit. Oh, let's put this to 10K. Just 10K potentiometer. Come on, this is not correct here. This is a 10K. Yeah. So we're gonna check on the voltage on the 10K potentiometer, and also on the pin 3. So the 10K potentiometer is more as a voltage divider. Okay, and then you have the pin 3 is a non-inverting pin, and then pin 2 is a inverting pin. Let's put let's make a small table here, small rule of the compressor. Okay, let's label this. I'm gonna call this A. This is gonna be B. Okay, so here we're gonna place a small how do you say, a small rule of how the compressor works. So if A, let's start this. If A is greater than B, then equal, the output is gonna go high. So it's gonna go H, high. Let's finish that, high. If A is less than B, output goes low. Okay, so this is a kind of fundamental of the compressor. So if this voltage here it goes high than the B, then the output gonna go high. Otherwise, it's gonna go low. So let's see that now. So you can see here the pin B is higher than 3. So if we see here, if A is less than B, then output is low. Exactly, the LED is off. And if A is greater than B, then output is high. Oh, let's connect this one here to ground. Okay, and also gonna add another voltmeter at the end here. Then you can see when the output is going negative and positive. Put power on again. Now you can see is negative, is minus, is low. Okay, So let's say that A is greater than B. So we increase as you can see, the voltage is increasing over here. The LED turns on, and here you can see, okay, voltage is just the voltage is 2.5, and exactly 2.5 turns on. We're gonna create another one here so that we have the full scale of full understanding of one side of LM32 form. So I'm gonna stop the simulation. Simulate this, and now you can see the LD is, they are both lighting on. Okay, let's give an also voltmeter here. Okay, so we have it there. Simulate this again. The LD, they are both of them, they are lighting. You can see the reference voltage is 2.5. Okay, so when we increase this, when we go closer, one LED turns off, and you can see it's going negative. Okay, and the voltage here is 3.3, and the other one, the upper comparator goes on. Okay, keep remembering this these rules here. Okay, at this point here now, A is greater A is greater than B, so B is lower, then the A is greater. Okay, so when we gonna pull the torch back, the LED turns on, go all the way back, and then up turns off. So it goes minus 0. So this is low, and this goes high. So you can see we have a small window there where both of LEDs are turning on actually. Actually, this setup is called window comparators, these two of them. Okay, so we remember on this transmitter here, the sensor transmits data continuously to the receiver. When the sensor is triggered, the data on that axis break or goes low, then triggering the alarm on the other side. This is a CD4071 BMS quad 2 input OR gate, and we have three packages actually, different ones. So you can see here we have the two for the 2 inputs, and we have for the 4 inputs, and we have for the 3 inputs. The voltage here, it's about 5 volt to 20 volt DC. So we're gonna go ahead to the Proteus and try to design a simple circuit and simulate the working of a OR gate. Like so. Then you're gonna add some voltages here. Let's say 5 volt. The circuit look okay, so we're gonna try to simulate this. Put power on, nothing happened. We bring the torch close to the LDR sensor, and then you can see we have an output LED turns on. Okay, we go back again, LED turns off. Bring this one as well, LED turns on as well. Oh, I've given the wrong connection here. Yeah, there you go. Simulate this. LED turns on. Take a torch away from the sensor, turns off. So you can see this actually any of these, if it's triggered, the LED will turn on. If both, same on. So let's try to give the names here so that you understand how it's working. Let's move this a little bit, just make it more nicer. Yeah, like that. So we're gonna add some labels, okay? We're gonna call this let's say X and A. I'll call this A. This is gonna call B, and then over here we're gonna call this C. Okay, and then we're gonna draw here a table, a truth table of OR gate. Script. Okay, so we have A here, then slash that we have a B, slash that we have C. Okay, so this is gonna be input slash input slash output. Okay, I wish I could have a line like that, could be more easy. So A and B, okay. So put it over here. So then we say if input, so let's say the truth table is 0 here, slash 0, oh 0 slash 0. So meaning if input A and input B is 0, then output is 0. Okay. If input A is 0 here, then slash input is, let's say it's 1 here, then the output is gonna be 1. Okay. If input here is 1 slash 0 slash 1. So if either input A is 1 and input B is 0, the output is going to be 1. So either between A and B, any of them high, the output is also going to be high. If both, if input A is high, 1 slash 1 slash 1. So here we go. So as you can see here, this slash just representing actually should be a line going down. So if we see at the first one here, if the all inputs are 0, then output is 0. If the one of the inputs is 1, the output is 1. So in case you can see here the output in the input A is 0, input B is high, then output is high. If input A is high and input B is 0, the output is high. If both are high, then the output is high. Okay, so these are simple. There you go. It's kind of small, but I think you can get it. Yeah, so this is called a truth table. Okay, let's put it inside here, up here. So that's why you see here, if we put the simulation and we can put an LED here. Let's say we remove this sensor. Okay, so both are off. Okay, so all of them are off, At this stage now, this is the first table here, so it's 0 0, nothing happening here. If we increase the touch to the sensor, the LED turns on. So there's a second. This is a now one of the input is 1, so the output becomes 1, and if both are high or 1, the output becomes also high. So you can see that. So this is a simple explanation of CD4071 OR gate. Okay. So the schema of the receiver here, we have a H212 decoder, a ref transmitter, we have a CD4071, it's a quad 2 input OR gate. Then you have a couple of transistor here and the LEDs, UM3561 for the Surrain. This circuit here, I'm still testing this circuit, so we're not going to talk about it. So we get a signals here, we get 4 signals here. So the X positive, the positive X and the negative X axis. We have Y positive and Y negative axis as well. So that's why we have 4 of them. And then we take all these signals. We take 2 signals here for pin 1 and 2, and then we bring it to one of the pin here. So you can see that it's coming all the way. It goes inside to pin 9, and then pin 8 is going to output. You're going to pin 4. So what I'm doing here, I'm just collecting all these the inputs here and putting all them together just to pin 1, pin 10. So the output is going to be only one output here out of all the 4. Collect them and then I'm going to present here as 1. The signal goes all the way to the op-top coupler. Okay, and this here is just to ensure that when there's no transmitting on this circuit here, the off system stays off. Okay, when the transmitter is happening, this LED here will turn on, also activating op-top coupler and keeping the system ready to receive any interrupted signals. Okay, and then you have a small capacitor over there. This for a simple delay to cancel some delay. I'm gonna demonstrate this right now. Okay, I'm gonna put the power on here. There you go. So zoom a little bit there. So you can see already the LED is turning on, meaning that there's already transmitting is happening. If I disconnect the power here, the LED also turns off, meaning there's no communication between these two boards. I put the power on here, and this means there's a communication. Now I'm gonna try to tell the sensor in different angles. Okay, so you can see that is one angle. So for example, this is now X positive. Okay, you can see that right now. So this is gonna be now X positive, then X negative, and then you have Y negative, Y positive. Okay, so at this point here is only this one, and you'll see one LED is lighting. If you go backward, the second LED is lighting here. This meaning is a negative X. Okay, back to level, power goes off. You go to the tilt to the right, the Y negative, tilt to the left, and you can see we have LED lighting also indicating Y positive has been triggered. Okay, so the circuit send these two boards, they communicate continuously. When the sensor is triggered, so then the communication on that axis stops actually. So the signal gets interfered, and that means you're gonna send the signal to activate the alarm on. So the capacitor I added there, if I remove this capacitor, for example, now you can see I can twist all the way and the sound is continuously. If I just move this small capacitor here, that's gonna happen. There's this small delay happening there, and it's not good. So we add a capacitor there to cancel that noises. Then now you can see it's no more any those noises. Okay, and then you can change also the sound here. Okay, we have that kind of change that to something else. You have that siren, police siren. Okay, change that to another one, so it has four sirens, and then you have that. Put this back, then you have that. Okay, so I'm using a small speaker here, but actually I can use one of these. This is actually came out of one of the siren, and this is really more louder than the other one. Okay, so when the sense is triggered, okay, change that. It's very noisy actually. So that's all working, and from this stage now we're gonna go to the computer and design on the PCB itself and try to make it a nice looking, because now it's kind of messy with the wires everywhere. So I'm gonna make more of the PCB it's gonna look more neat, more something like this, something nice together. So that will be on the next video.